Hello everyone and welcome finally back to the Odd Machine Factory's Garage series. After a long pause we're doing again some YouTube stuff, and today we're looking into the space claim for the new engine and driveline in the Drift Legacy project. But before jumping into that topic, I would like to explain a little bit what caused the pause in this YouTube stuff. So let's start off with this one, my XJ6 Jag. So this car had been off the road for 15 years and I did a fairly large body restoration to it in 2022. And last spring I promised that this will be a wedding car for a few of my friends. So I did multiple weddings with it, and before I could do that I had to, of course, make it road legal and inspect it and so on. So I needed to refurbish the fuel tanks and fuel pumps and fuel lines and a lot of electrical stuff. So a lot of small things that you need for the car to be reliable and legal, and which took a lot of time. So I prioritized that over the Drift Legacy project as this was promised to be a wedding car for a few people. And I also enjoyed it myself. I drove 5,000 kilometers with it during the summer, so that was a really nice thing after a large project. And another thing that happened in the spring was that I found actually, or got a hint that there is a 1969 Ford Escort Mk1 in a barn which has partially collapsed, and it was from the original owner left there. And I went to see it, and as the roof had already come down, luckily not on the car but quite close to the car, I decided that I want to save that car before the barn fully collapses, and I did. So I bought the car, got it running, got it driving, and then had to renovate a small shelter for it in my yard. So now it's safe and having its 35th year in the barn. Now in a different barn, but anyway, a barn. And I hope that I can present that to you later in more detail. But that's what I saw as more important than the Drift Legacy build. Then a third thing that came along was a truck. So I bought a small truck which I can use to transport the track cars and the project cars and donor cars and so on. So I thought that that's quite handy in the future. So I bought that and actually built already some car ramps and a winch setup for that, and we can take a look at it later on. But I also thought that I had a good chance and a fair deal about the car, so I wanted to prioritize that as well on in front of the Drift Legacy. But that's it for the excuses. Now let's continue checking out this project. And like I said, let's first take a look at the space claims. So here's actually an engine that you haven't seen. This is a 2004 XJR engine, so 4.2 liter supercharged V8 from the factory without the VVT, so the variable intake cams, which the XKR engine has. But this is the engine that I'm planning to use for now in this build, and let's figure out the second setup later if there comes a time that we need to swap out the engine, for example. And I bought this as a bare engine without any accessory components. So now I just threw on some components which gives me an idea how much space we need in which direction. So now it has the intake manifolds with the charge air coolers and the fuel rails from the XKR. It has the S-type thermostat housing. It has a combination of different auxiliary components. So now we have there basically the full auxiliary belt layout and all of the auxiliary components that we need for the engine to run. So this is giving us a very good idea where to position the engine and what type of space we need around it. And one thing that I already needed to consider and decide was that I had the supercharger for this XKR engine, which fits also to the XJR engine. It's the same unit, but as it would have come so far in the engine bay that it would have pushed through the bonnet, I decided that I will turbocharge this engine. So I sold the supercharger, and then I wanted to leave the nice and already available intake manifolds and injectors and fuel rails. So I will use those from the XKR engine. And the situation is now so that we still had some challenges in the height direction. And as you can probably see, I had to take out the reinforcements from the bonnet to fit this package in here. And what I actually had to do, I don't want to modify the subframe because that's not legal. So what I did is that these engines actually, or these cars come from the factory with a raised chassis version, which is called the Outback. And you can, in a moment, you can see that I fit some spacers between the subframe and the main frame rails, which are from the Outback, so I could lower the subframe to give us a bit more space in the height direction. Then, as you can see, in the width direction we have quite a nice situation. So Subarus of course come from the factory with the boxer engines, and these Legacies and Outbacks you can even get with the 6-cylinder boxer, which is a bit longer. So there's quite a nice space here throughout the whole engine bay length in the width direction. So very nice space. We can fit in the exhaust manifolds there and all of the necessary components. So the width direction is really nice in these. And then, as we will have a turbocharger in the engine bay, I wouldn't put it on this side, as there is a steering shaft and the steering column there. So right there, it's quite hard to fit there the downpipe. You could do it, but on this side we have a better space for that. So I will fit the turbocharger in this area, move the ABS pumps and pipes so that we can fit the downpipe from there, and then I can show you in the further episodes what kind of a exhaust layout we will have there. But I don't see a issue there. I think it's fairly nice space that we have for the hot components as well. Then on the longitudinal side, in the front end we have a lot of space. This is like very nice space. We could probably fit 3 radiators and a fan here, but for some people this might be an issue, at least for the hardcore race car builders, this could be even a showstopper. So as we compare the engine longitudinal position to the front axle, there you can see the hub, and if we raise our view here, we can see that the last cylinder of the V8 is on the front axle. So the engine is hanging quite far in the front. But for me, that's not an issue because I want to keep this street legal, and there are some things that I prioritize on top of the optimal weight balance of the car. So I think it's gonna be fully drivable, but not of course optimum with this position. But what is nice with this setup is that we can access the starter bolts, all of the auxiliary component bolts, the gearbox bolts. So we have quite a nice serviceable package, which is possible to always also get legal in Finland. So that's what I prioritize. And the reason why the engine actually sits so far front, we could of course pull it backwards, but we have a brake booster there, and then the clutch main cylinder, which are limiting the partially limiting the position of the engine in the longitudinal direction. But one of the key reasons for not moving it backwards is actually the last primary exhaust port compared to the steering axle or steering column. So if we would move the engine backwards, it would be a really tight place to squeeze in the exhaust headers or the primary pipes for the exhaust, and I don't want to do that. So let's lock this as the position for the engine. Then if we look at the engine from the bottom end side, we see that from the oil pan point of view, we would actually have quite a nice space here between the subframe and the oil pan. And this is partially due to the fact that I prepared for this mounting study, and I threw in here already the upper and the lower sump, oil sump from the S-type engines. So this isn't the XJR sump, it's the S-type sump. And as we have some limiting factors with the exhaust header and then the brake booster, we can actually fit here the XJR variant, which is a bit longer from the sump point of view. So I will use that one as it's supposed to go with that engine. And then we have a bigger sump volume, which is always nice when you're drifting with high RPM. Then if we take a look at the engine mounts, you could actually see that if I use these original mounts, they would be basically a direct fit. With a small additional bracket, you could fit those and use the rubber mounts as well. But the actual mounts are aluminum, they are quite thin. So if I'm clutch kicking this and giving it a lot more torque, I think it's not a wise idea to use those, and I don't even want to know how many kidneys the rubber mounts cost from Jaguar, so I'm gonna build my own mounts there. And the idea is that I have this also in the Black Scorpio. I would mount the engine to the actual main frame rails of the car, so that I can drop out the subframe whenever I need. So if there's a problem with the bottom end, if I need to fix the steering column or do something to the steering geometry, I can just pull out the whole front axle out of the way without dropping also the engine. So I think that's a fairly good setup with these cars that are pushed to the limit and then might have some bearing issues or whatever. So I will most probably build it so that we can mount the engine to the actual frame rails of the car. Then you can actually still see the front drive shafts from the Subaru, so I can show you later on what I will do with those, but those are there just to keep the hubs together so that the wheel bearings don't break. So I just left them hanging there. Okay, then let's take a look at the gearbox side. So here we actually have a quite nice setup. So I haven't done any modifications to the body of the car, and I have already lined, I'm not sure if you can see it from here, but I have aligned the propeller shaft so that I can see that the gearbox and the engine positions that I have selected now work also with the new prop shaft and driveline alignment. So there's actually even a final drive hanging there. And the gearbox itself, it's a funny piece because it fits straight into the Jaguar V8, which never came with a manual gearbox from the factory. So if we go beneath the car, we can see that we have quite nice space here all around the gearbox. So no need to modify the body, at least as far as I know. Now we can access all of the bolts and we can access the starter and everything there. So it's a fairly decent setup. But the gearbox itself is from a Jaguar 2.7 liter diesel. So actually the diesel gearbox for some reason bolts onto the V8 petrol or gasoline engine, which is quite odd thing, but it happens. And the actual gearbox itself, it's the same base design than the BMW ZF gearboxes, which are in the E60 530 and 535D engines, so the GS653Z. And the difference is of course in the clutch cover, and then the clutch shaft is different, and then actually the gear ratios are closer to the gasoline engine variants in this one than in the BMW ones. But the base design is the GS653Z. The flexible joints are the same than in the BMW, so it has the 110 millimeter pitch, so it's a large flex joint. And then the propeller shaft or the drive shaft has quite big U-joints. And then if we go to the back, it has another flexible joint, which is the same than in the front. And this drive shaft or propeller shaft is from a Jaguar S-Type. And it's the same in all of the models, just like the diffs. So the supercharged S-Type R has the same propeller shaft, same flex joints, and same diff than for example the 3 liter V8 automatic. They have even the same gearing, so the final drive ratio is the same. Also, the drive shafts, which are currently missing, they are at least from the outside the same. Some rumors say that the smaller engines have the hollow ones and the supercharged versions have the solid cross section for the drive shaft. But let's see. I will use the ones that I have. I think I have four 4 of these. It's actually a Ford 8-inch differential, which is in the Jaguars. I have 4 of these, and then I think four pairs of drive shafts. So at least we can test it out how it works. And these final drives or differentials, they didn't have a lock from the factory, but I have an idea for that as well. And of course we can run it first with the welded lock, as I have so many of these. But I have a little surprise for you in the later episodes, which I can show you. There's another quite common final drive which has the same dimensions than this one, so we can compare those, and we can even see that if we could get some locks transferred to this differential housing from the other differential, which is more commonly used in the performance cars. But that's it basically for the space flame. So currently I don't see any showstoppers here. I think we can make things fit. We have definitely all the necessary parts for the driveline, and now it's a matter of just continuing the build and figuring out the details. But now I don't have any additional projects which are disturbing the build, so I can continue working on this and publishing more frequently these videos from the build. So if you like this video and build, please consider subscribing, like the video. That helps me at least in knowing that if somebody's interested in the topic. And then for the engine performance simulation topics, the models, simulation models are so far that I can start publishing the models and results and studies quite soon, but I will keep them in a separate series, so keep an eye out for those as well. I think it's a very interesting topic, very interesting things we can learn from them, and I haven't seen that in the YouTube world yet, or anywhere in the internet that much. So if you're interested in that, please consider subscribing as well. But then this is what we were supposed to go through today. So I would like to thank you for your time, and I hope to see you in the next one.